Hi, welcome to everyone's favourite segment, Mailbag. Let's get straight into it. I haven't done it for a while. You may recognise the tape, Infinity PV. We've had some of their stuff on here before, so they're having a second suck of the salve. But their stuff is really cool, so let's... Here we go. Now we're talking. So yeah, they it's not more of the same, although they pretty much are a one thing company, but they make many variations of. Oh no, cool. We have some boards this time, not just the very funky printed solar cells, which we've seen before. These are awesome. Are these new? Yeah. Oh, hang on, 3M. Woo. It's good shit, let me tell you. What is it? Yeah, the printed solar cells, which are great, flexible solar cells. These are absolutely awesome. And so we've got, I don't think we had one of those, that format before. That's really cool. And we've got, looks like a double one. Hang on. There, the contacts coming out. And, there we go. But they can print these any arbitrary length they like. And they're real, printed organic solar cells for Dave Jones' EEVblog. Awesome. Thank you very much, Infinity PV. But not just the printed cells this time. They've got some brand spanking new boards. So let's check them out. Oh, this is ridiculous. Look at this. It's a USB, it's a dispenser, kind of like a dispenser kind of thing, but it's like a USB, and you just pull it out. That is brilliant. Oh, wow. And you wind it, you wind it back in with the USB. We'll take a closer look. This is great. I love printed solar cells. These are brilliant. These things have a future. Can we buy shares in them? They're not hugely efficient, but that'll come with time. But I don't think they'll ever be as efficient as all your regular types of rooftop solar and stuff like that. They probably won't ever be as efficient, but it doesn't matter. They're cheaper to print, and you can print them in any length, and they're just so darn useful. These things are just great. They're the duck's guts, really. And look, you can see that they can just, because these are just printed, they can just print anything they want on them. So, custom message or whatever. And I've shown you close-ups of, this before. So, yeah, you've seen it on a previous mailbag, but they can just print these. There's a couple of layers that go into it, but you can see the serial nature of it here. So here's the negative. For example, and you can see they go under the big bulk underlayer and pops up here and then goes under and there. So they've got all these in series. Fantastic. Unfortunately, it's very overcast out there today. I haven't got full sun, so I have to do a separate video characterizing these things or something, because they really are terrific. But look at this, they've custom made this for me, Dave, EEVblog, if you can see that, and it's a 2600 made in Denmark. I don't want my Danish viewers. 2600 milliamp hour lithium ion battery in there, and USB 5 volt 1 amp output, and you can just pull out this solar cell. Now, of course, in full sun, this is not going to charge it very quickly at all, and of course, I'd have to do experiments on that to see exactly how quickly it can charge. 2600 milliamp hours, that's a fair decent capacity cell, but of course you pre-charge it. But if you're stuck in the middle of nowhere and you've got all the time in the world, then you can certainly wait for it to charge. But that's great. I'm going to whack that in the backpack when I go out back. Terrific. So this big array here, just sitting here in the lab with my regular overhead studio lights on. We're only talking like 22 microamps. I mean, it's, bugger all short circuit current. And of course, if I put my hands over it, you can see it drop. There we go. And it's, indoor light. These things aren't efficient to begin with, let alone indoor light like this. And if I switch on my studio lights under here, I think there's 200 watts worth of compact fluoros under there, and it's like a milliamp. These things are not efficient at all. And that's a reasonable volume, area, if you did that as a square area for a regular solar panel. But anyway, this is not you know, sun equivalent. So, you know, don't get all excited. But yeah, not much. Look, current's going up. So is that like a temperature thing? Because these bulbs are now in close proximity. That'd be heating up. They might be getting more efficient. What we've got here is the OPV 3W60V. It might give it away. 3 watts capability, 60 volts, maximum power point conversion as well, tracking. So that's brilliant. These are little boards that you can do USB charging and loads and stuff like that. So I'll link them in down below if you want to check them out. I'm not going to experiment with them now. I really need to like have full sun outside. The sun, it is dark and gloomy and overcast out there. It really wouldn't be, you know, ideal test. I'll have to do a separate video on these things. But this looks really quite good. 3 watt capability, 60 volts. There it is. Up to, okay, so an 8 volt to 66 volt open circuit string, and maximum power point range only goes up to 42. You can have 2 parallel inputs. Maximum 1.5 amp current output. This is a really groovy little addition to the organic printed solar cells. I love these things. So definitely going to have to do a separate video having to play around with this, see what we can get out. As I said, they're not hugely efficient, but the fact that you can print them and print them at such low cost using simple machines is just fantastic. So, linked down below. Hi to all my Austrian viewers, not Australia, Austria. Thank you very much, Johann Natter from DSP Crowd Electronics in Österreich. Anyway, that's the Austrian pronunciation or German pronunciation of Austria, apparently. Who knew? There you go. Let's see what we got. So thank you very much. It's a, oh geez, I'll get that off later. It's a that's a Raspberry Pi, dspcrowd.com with a dash. That's looks like a Raspberry Pi type thing. It's all done in KiCad for all you KiCad fanboys, with a little breadboard on top. That's neat. Let's check it out. Good on you, Joe from DSP Crowd Electronics. Sent in this puppy here. It actually converts it actually connects a Raspberry Pi to a DEO Nano, and it's got some stuff on the. It's open source. There we go. Have they used my new? No, they haven't used my new open source symbol down there yet. A few people have. Quite a few projects out there have actually started to use it. Anyway, what it converts is an FPGA kit, which you've seen before, which is the. I'll get this out of here, which is the DEO Nano. Nice little, starter FPGA development type board. And it actually connects that. So it's designed to connect that into there like that. Oh, does it even... Oh, hang on. Does that... Oh, it's hitting the... It's 3-way. Is it supposed to... No, that's a fail. I was going to say, that's what it's supposed to do. Maybe you've got to take off the plastic thing to make it work. Okay, fair. If that's the case, fair enough. Anyway, that goes in there, and then your Raspberry Pi sits under the bottom. They've got the extended headers like that, so you can combine in a development system the power of a like a Cyclone. What is that? A Cyclone 2 or whatever. Anyway, no, Cyclone 4. Sorry, Cyclone 2 is pretty old. Cyclone FPGA with a reasonably powerful ARM processor in the Raspberry Pi. And you've got some breadboardy stuff. You've got dual Ethernet type interface. I won't go into all the details. And, of course, to power it up and experiment with it can take hours and hours. But that looks like a nice solution if you're looking to combine FPGA functionality with a Raspberry Pi, because the Raspberry Pi ecosystem, tons of development tools are available, lots of big community, everything like that. Sure, you can get, FPGAs with the built-in ARM cores and that sort of stuff that combine it, but this is just a neat way. If you like this platform, you like this one, and you want to join them together, it's a neat way to do it. I like that. Good on you, Joe. Link it in down below. Thank you very much, Tim Savage from Katoomba. Just up the mountains here. Oh, wuckers. This I think I'm going to like. We do like these here on the EEVblog. It's a teardown. Spoiler alert. All right. Ta-da! I do believe, well, I kind of, like, not asked for it, but Tim has very kindly sent in a HP 48 G for, oh yeah, for Teardown. Because I did a poll, like, comment poll last time asking if I should have torn down that brand new HP 48G, and everyone said, no, don't do it. So Tim's very kindly sent in one that we can rip apart that's already been ripped apart or something. So awesome. Let's have a look inside. Thank you very much, Tim. Yes, these are a complete pain in the ass to open. The metal face is glued on with the plastic heat stakes, as I surmised in a previous mailbag video. Anyway, this is 20 years old, still going fine, apparently. Let's crack it open. Anyway, if you take the plate off, for those HP key fanboys, there's the mechanism for that. Of course, they're known for their excellent tactile feedback, so they do that using this plastic complete cage type thing, and then of course they'll have tactile domes on the board. They'd be like, Snaptron or some other top quality dome with good feedback, but yeah, that's nicely engineered. Yes, it still works just fine after 20 years. Bloody ripper. And here we go, we're in like Flynn, and here's the whole thing. You can still see the battery contacts coming out here. It looks like we've got metal, haven't taken that out yet, metal shield, all on the bottom. Oh, well, at least up to the LCD there. Very nice. And around. Now, Tim has made a couple of original modifications back when, upgrading the RAM was a big deal. So he's just hacked it in, upgraded it, and Bob's your uncle. Once again, it didn't go back together very well because these are very tricky to take apart and put back together cleanly. But yeah, that's the mod for the memory upgrade. And then we've got ourselves the main processor. Of course, it's a custom HP job, but it's manufactured by NEC. They wouldn't have manufactured their own ones. And then we've got some Epson Lcd drivers. There's two of those. SED 1181 for those playing along at home. And of course, these are just regular SRAMs. None of this DRAM rubbish, so they hold the contents on the smell of an oily rag. And of course, we've got a large cap to back that up while you're changing the batteries. No worries. But check out all the test points they got on here. Imagine the bed of nails to test this thing. Wow. But yeah, they would be thoroughly bed of nails testing each board before after they're manufactured. And there's the bottom of the board, and we've got there's the zebra strips for the dot matrix LCD, and there's the keypad. Look at all the heat stakes. These are the evil heat stakes that holds together the entire case and everything else. Look how many holding together that keyboard. But you need it because HP engineer keyboards well, and you don't want any, soft spots where, oh, this key's a little bit softer than this one up here because you didn't put enough heat stakes in. And that's what you get when you rip out the heat stakes, and we're through to a sheet. It's got the good old-fashioned HP logo, none of that new modern rubbish. And there we go. Oh, look at that. They aren't tactile domes. They're using the... That's interesting. There you go. No, they just use the carbon film. I was going to say paper, but it's actually film. And they've just got, standard sort of land patterns for those. Aha, there we go. Found the tactile dome. It's not on the board. It's actually embedded in the plastic sheeting in here. You can see that tactile dome in there, and that's what causes the famous HP snap. So that's just levered plastic, but you combine it in there, and this is not Feel-O-Vision. Yep, that gives the famous snap, just based on the plastic dome like that. Neat. That's a really elegant, low-cost solution to do it. Better than like metal tactile domes, which aren't particularly cheap. But yeah, once you've got your process down right for that plastic film, that's pretty jazzy. I wonder if HP make that themselves or whether or not they actually get that contracted out. Wonder who makes it. Does anyone know? Leave it in the comments. And you can see that the carbon traces, these are just pressed
straight onto the board in there. So it doesn't even go through a zebra strip for that. Neat. If you can make it work, well, you can make anything work with 10,000 bloody heat stakes. So thank you very much, Tim, for sending that one in and sacrificing it, because you really do have to sacrifice it. I mean, to get to that keyboard and actually have a look at what's doing that, you know, like to put this back together, oh, you can maybe get it and back together. It'd be a mess. It'd be an absolute mess. So yeah, these things are not designed to be taken apart. Everything heat stake. You saw how many heat stakes. Look at all the heat stake mess. It cut off each individual heat stake. It's ridiculous. How many were there? Crazy. Bloody Hewlett-Packard, but these were bloody good keyboards too. Thumbs up. Thanks, Tim.
Probably 10th sucker the Sav, I think. They must hold the record, Digilent. I love Digilent. They just make everything. They make lots of cool stuff. So let's check it out. They've obviously sent in some new demo-y type board. So it's got one of these pull tabs. How convenient. Fragile. Wow, really? Oh, look, fail. Complete and utter fail. What a load of garbage. Unbelievable. That's, here we are. No, it pulls, it's a half and half. You got to pull from either side. So I probably had to do two and then slam my hands together. Oh, bloody ridiculous. Anyway, see what Digilent has said. Fragile, fragile. It's another analog discovery. Why? Hang on, I was fooled. It looks the same as the analog discovery, but it's not. It's the new, I presume new, digital discovery. So, logic analyzer. Type. A thing. I would presume. Wonder, high-speed inputs. Wonder if it does like, can generate like high-speed. I wanted something recently that could generate high-speed custom SPI stuff and things like that. I wonder if it can actually generate stuff, whether or not it's high-speed inputs. No, they're just inputs, and there's inputs and outputs. Yeah, I wonder if that'd be nice. I wanted like an SPI like protocol generator for like testing stuff and things like that. So I wonder if it can do that. Let's find out.
It's a logic analyzer and pattern generator as well. So I might, I'll have to do a separate review on this, but I'll show you the software very briefly. Yeah, $199 US. It's a bit pricey for what is probably essentially just an FPGA in there, but you're paying for the software and the capability in there. So, you know, you could almost say it's commodity hardware. Oh, you know, there's actually a fair bit in there. There's double-sided load and everything else. Actually, let's crack it open. Yep, essentially it's just a Spartan 6 FPGA and, you know, just a bunch of miscellaneous stuff. You got, you know, FTDI and things like that. But, yeah, this is the product we were actually going to do. Just a Spartan 6 FPGA to generate digital patterns. So this is a logic analyzer. Like, the logic analyzer market is just completely flooded. How much value can it add there? But where it can add it, as is a digital, I hate this black solder mask. My camera just goes into like this is like low light. Should gain that up, should it? Anyway, bloody hell. Let's go check out the software. So it's basically just an FPGA that can do the high-speed digital pattern generation and also the logic analyzer stuff as well. I don't think the logic analyzer is too advanced. I'd say it probably doesn't have, you know, adjustable trigger level and stuff like that. I'm pretty sure it wouldn't. Not with that sort of circuitry. So what's that chippy there? That's just our buffer, is it? Have to have a look at that. And of course it has the requisite diode protection on the other side. Gee, that silk screen's busy, isn't it? With all the squares around everything. Oh. Right, so if I have a very quick look at the software, and this will not be a review, then we have the various supplies. The output voltage we can actually select 5 different levels from 3.3 to 1.2. It would have been nice to have a 5-volt option there to output, but I know that, you know, to get the buffer translators to do that. Anyway, it does have, look, adjustable threshold voltage. There we go. Oh, that's just going down. Okay. So you can't adjust those individually. Okay, there we go. Then we can just set the individual outputs to all up, like float, and then you can set individual ones to Z as floating, of course. And then we've got the logic analyzer. I won't go in there and play with the logic analyzer. That's time for a review. What I'm interested in is, can this, well, you can do static I/O. There we go. Look. Well, okay, we can adjust it and then read it and feed stuff in and just see the LEDs and stuff like that. That's kind of neat. And then you can do protocol stuff. This is what I'm interested in. And by the way, you can just generate patterns, a pattern generator. So I was actually going to design a product that actually did this because I wanted something that you can generate, SPI, I2C, and UART and other signals up to very high rates and stuff like that. Hence the FPGA. And David and I were just actually discussing this project before we opened this, coincidentally, and how I looked before, and they didn't have the ability. I looked at the previous, like the analog discovery and stuff, and all it had was the pattern generator like this, and that didn't actually do it. But this protocol one, bingo, we can generate UART, SPI, I2C, and SPI can go up to 50 meg. Thank you very much. That's unbelievable. Unfortunately, a little bit of a limitation. It doesn't look like you can, do like, can you type in your own frequency? No. Okay, so it's fixed divider frequency. That's a bit of a shame. It would have been nice to do that. But anyway, to go up that high, and the ability to do that is quite nice. Anyway, look, you've got quad writes and reads for the SPI, and this is just a simple mode. And custom mode, looks like you can script the whole thing. Beautiful for all you script fanboys. Wow. Neat. Anyway, this is very powerful, so you can write data out. Is it only in, hex, I guess? Binary? Okay, right, yep. So you can actually write data out and just generate a high-speed protocol generator. So this does the basic business. I'm very, very happy with that. That will come in handy for generating, test and demo signals for the various protocols. So that really is quite neat. I'm very happy with that. And UART, what can the UART go up to? Oh, there we go. Once again, 50 meg UART. Thank you very much. It would have been nice, yeah. Once again, if you could set that, that would have been really, and 921, that would have been really nice. But hey, this is really rather handy. I'm liking it. And I2C, up to 10 meg. Wow, your bus capacitance is really going to matter when you're getting up that high. That pull-up, that 2K, that nominal 2K2 pull-up, in the standard may not be enough. Anyway, this looks like it could work a treat. Separate review will have to come because I can't play around too much now. Thank you very much, Matthew Fields, and hi to all my viewers in Baltimore. I can't help it. Every time I think of Baltimore, I think of the sum of all fears. Like, they nuke Baltimore. That's a great scene, by the way. Not that I wish for Baltimore to be nuked. It's just I like nuke scenes, and it's very cool. Anyway, if you haven't seen the nuke scene in Sum of All Fears, do yourself a favour. Anyway, that's a Jack Ryan thing. That's in the Jack Ryan universe. So, anyway, a whole bunch of stuff. So, thank you very much. Let's note. Oh, always wanted one of these. Oh, yeah, we've got a whole bunch of stuff. Obviously, fed up with me using this ridiculous thing to open packages, and has sent a Nipex? A Nipex, it looks made in Germany. Oh, yeah. 1000 volt rated, just in case you cut through cables. Wow. That's great. Is that blade, it's got to be, is that blade replaceable? I don't think it's replaceable. That's a bit of a shame. It's not like a replaceable Stanley knife. Anyway, that's really rather cool. I might start using that, but instead of that, because this one's a bit more dangerous, it's exposed. Love the danger. Anyway, tools, thank you very much. We are, Pico Soft Grip Chip Lifter. We are make a chip lifter. Wow. I used to I still got the proggy one, to lifting up dip chips and stuff like. It's a chip lifter. Brilliant. So I've got a whole ton of tools. Once again, Nipex, and it's got a I've got to push it. Do I push it down? Oh, that's pornographic. I like that.
Very nice. And hang on, more oh, thank you very much. Gone to town. We're Allen key set. Awesome. And haven't even gotten to the good, well, the old thing. Oh, look at it. It's just fantastic. And so spanner set. This is brilliant. Thank you very much. Here we go. Obviously sick and tired of me. That's a box cutter. That's a Schmick box cutter. A Martor branded box cutter. It's got the little blade in there, and I think it's going to stay on the bench. Now we have some vintage stuff. Oh, beautiful. Micronta Tandy / Radio Shack. I think I lusted after this back in the day. Oh, it's like back when auto ranging was like a big deal. Oh, yeah. 2-minute teardown. Fantastic. But one of these, oh, geez, that's encrusty, Nick. It's the Philips multimeter. That is in the worst condition I've ever seen. Someone's gaffer taped that back together. Wow. Another 2-minute teardown. Awesome. Thank you very much. Matthew's a long-time viewer, but is a new fellow blogger. Started up a new YouTube channel, German Tool Reviews, where he reviews German-branded tools. Awesome. So they're all made in Germany with the exception of the Wera L-Key. A couple of crusty multimeters. So where's his channel? Hasn't linked it in. I'll try and find it. German Tool Reviews. And I'll link it in down below. Check it out.
Oh boy, check this out. This was crusty as. Look at the cloth tape on the side has just completely worn off. So somebody put the tape on this and then wore the absolute crap out of it. Wow. Anyway, I used to lust after one of these things because, you know, like it just looks like a solid bit of kit. You know, the PM2718X RMS, true RMS multimeter, NIST, traceable calibration, 93. Thank you very much. But these were, they're pretty high spec units back in the day. I have to pull up a spec sheet for it, but you know, like, yeah, they use the shrouded plugs and stuff like that, weird ass ones that come in the side and stuff like that, but they just looked like it had a lot of functionality. I just, you know, it wasn't your traditional handheld multimeter. 4 C-cell batteries in the puppy. You gotta wonder how long that would last. I mean, you know, LCD on the thing, but probably not super low power circuitry. It's got external DC as well to power it, like 9 volts or whatever it is. So it must chew the old electrons there, I reckon. Anyway, look at the fuse holder down in there, little M205 job. None of this HRC rubbish, or is it? Oh, yep. There we go. They at least use a little ceramic. Check it out. You can actually see the sand granules in there inside the is that presumably, yeah, glass. And great, rather than like, you know, like the ceramic just, you know, solid ceramic form or whatever, they've just put the sand inside just to stop it exploding a little bit. Yeah, not exactly hugely HRC. It wouldn't be a massive rupture capability, but better than your regular fuse. Battery, oh yeah, look at, shield in. Look at that. I think, well, oops, it was already broken, like it was already shattered apart, but look at that. There we go. We're in like Flynn, old school. Check out the range switch. There we go. That looks like dual wipe contacts, are they? Anyway, yeah, it doesn't feel the best. So they just have the gold and nickel, gold over nickel plate or whatever it is for the hard range switch there. And that's a real descriptive number. 000067. Yeah, that's got to be a custom job. Surely. Oh, hang on, I can use my new chip lifter. Oh, we are Pico finish. Made in Germany. Don't need that rubbish in there. Hang on. There we go. Look at that. Just bodged it completely. NEC job. That could be, yeah, that'd be the, what, is that the LCD driver? No, well, could be, no, that must be the combined processing. That's probably the ADC, I'd say, based on the analogy components around that puppy. And what else we got here? These are all like custom jobs. HSH84, what? Yeah. This is pretty much mostly custom. Wow. Not entirely, but geez. Anyway, there you go. All through-hole components, like, you know, really old-school type design. Look at the DIN connector on the side. Oh my god, DIN connector in a multimeter. And as was par for the course back in the day, they didn't really have, you know, input protection wasn't really a thing back then. You know, now we have the CAT standards and everything else, very stringent requirements to pass, and they've got MOVs and poly switches and diode protection and all sorts of stuff. But yeah, back in the day, yeah, no one cares about that. She'll be right. Is that colourful puppy there? I thought that might have been a colour-coded cap at first, but I think that is a MOV of some description. But there you go, very old school. But this thing did the business back in the day. It had lots of advanced functionality, like logic as well. It could do like opens and short, you know, different configuration. You know, it had dB and 600 ohm and 50 ohm. Thank you very much. You know, it's a real advanced functionality back in the day, and it was, you know, it was quite popular. It was quite a popular meter, I think. But yeah, not really much for your Joe average. You know, the flukes came along and put a stop to this thing, but I'm not sure how long it lasted. This was, well, still using it in 93, but I don't think they made it past the 80s, did they? And look at this, we have the manual in, like as new condition. It came in a beautiful pouch like this, absolutely freaking-tastic. Look at this, yeah, like it did, where is it? Yeah, it did logic and stuff, and it's got bar graph, you know, which was fancy-pantsy for the day. And yeah, where it is, like it does pulses and stuff like that, intermittent stuff and things like that. Set a bad level and relative references. Fantastic. Capture function. Here's the specs. And here's why they were sought after, because, yeah, 0.05% class, absolutely fantastic, you know, for a 4.5-digit meter of the day, really tight stuff, only 0.5% on the DC current, and 0.15 on the ohms is doing okay for a 4.5-digit meter, no worries there. But, yeah, have we got the battery life on this thing? Doesn't tell you. Is it there? Calibration interval, 12 months. No, it doesn't tell you the battery life. Check this out. Martor. Look at this. So, yeah, it's got the it's got the blade there, so you can slice and dice along there, and then hook under to get, you know, tapes and other ones that are already lifted and stuff like that. And this, ta-da, spare blade. Just like a Stanley knife. It's a Bobby Dazzler. Micronta auto range. Oh, it's, yeah, the bromine in the plastic. It's yellowed with age, but let's take it apart. Oh, look, it's got the pull tab on there for the fuse, for the M205 fuse. That was actually common back in the day. Not many people do that anymore. Custom manufactured in Taiwan for Radio Shack, a division of Tandy Corp, Fort Worth, Texas. Thank you very much. Let's crack it open. We've got the shielded top, thank you very much. Someone was thinking. And we're being mooned, there's not much there. Well, there's one chip. Everything else is through hole on the bottom. Somebody was drunk when they aligned that. Like, they must have needed a tiny amount of routing room on this side over here or something like that to get some traces out. So they put it on a, you know, usually you'd like 45-degree angle that, but they haven't. They've like 10-degree angled that or something. Hilarious. I didn't mind these type of jacks back in the day. It was quite common with the huge solder fillets on there. I found that they actually worked quite well. They were quite robust with time. No worries there. I think we're in for some goodness on the bottom. By goodness, I mean classic retro. How are you doing this? Yeah, that's phenolic-based board. None of this modern FR4 stuff, you know, proper, you know, fiberglass quality that we're used to these days. Single-sided board, because you had to save a few cents. Had everything on the bottom, hence why they probably had to angle that chippy, which is, by the way, haven't seen that one before, SXC1901F. I don't know. Anyone? Bueller? Bueller. Anyway, this was reasonably common back in the day to actually use like a standard wafer switch like this and not a PCB mount one, just the through-hole one. You know, you could buy these. These were, you know, practically off-the-shelf things, and they just whacked them in there and made a multimeter out of it. Look, got a little bit of shielded cable running from that point to that point, so that, yeah, they're running the input. There we go. They're running the input over to there. That's hilarious. Couple of green caps. Yeah, you don't get those much anymore, do you? And we've got a trimmer or two. No, just one trimmer. Couple of trannies. No worries. Bobby Dazzler. Look at that. Anyway, they're nice solid jacks. They, as I said, those work really well. Like practically like a jack stud kind of thing. Hi, my name's Jack Stud. So thank you, Michael, for that very generous package. All the tools and everything. Oh, look at that. Oh, shh. Hang on. Look at this. Flips open. Oh, yeah, Yep, I'm going to go off in the corner and stroke it and... Oh, yeah. I'll be back.
I got a cheap as chips Chinese one. There we go. Let's check it out. I will use my new... Oh, beautiful. And yeah, this came from, even though name was not on here, I know it came from, it's come directly from China, but I know Jonathan clued me up at the EEVblog meetup. Thanks to everyone who went to the EEVblog meetup. It's on the main channel. I put video of that. And he was testing, he was the one who did the do-it-yourself soldering iron in a day. Like, he wrote the firmware, hacked it all together, got it together, like started it in the morning, and then demoed it on my video at the gathering that night. So that was impressive. And he was he used one of these, Hakko. I've never had one of these, because they're actually quite pricey, and pretty specialized thing. A Hakko temperature thermometer, like soldering iron thermometer. So you put your soldering iron, and it's got the sensor. Anyway, this is not genuine Hakko. It's a complete rip-off one. And apparently they're like 20 bucks on eBay, or $20, $30 on eBay, like 1/10 the cost of a genuine one. But Jonathan has done tests on them, and he shows me that they're pretty darn accurate compared to the real McCoy. So... awesome. Yeah, why get a genuine one? It even says made in Japan on the back. This cannot be a genuine one. This has got to be a rip-off from China. But yeah, they're making it look like it's the real deal. Made in Japan, my ass. Thank you very much, Jun Chu, I think it is, from China. I don't even know if this is a mailbag. Mail. It's got mailbag on it. Okay, it's a UPS-y job. So, let's open it up. It's very thin. It's like there's, feels like there's like an old 5 1/4 inch floppy disk in there. It's not going to be that. And a couple of envelopes. Oh, right. Yes. From my former employer, Altium. Yep, they produced, it was like a greeting, they wanted to give greeting cards to customers with, ta-da, Dave Reed, by the way. Thank you very much, Dave. But he had someone else ship it. They asked me if they could copy my micro ruler, and they did. So it's an Altium micro ruler. I'll show you a close-up. Hang on. This has got gold-plated edges. Oh, yeah.
And there's the micro ruler, the original one anyway. It's, I'm not actually sure who manufactured this, but the quality seems quite reasonable. And if we flip it over... ta-da, there's my ugly mug. And, yeah, Altium, they're advertising Altium China, and there's the QR code for those playing along at home. And check out the wanky gold edge plating on that. Yeah, I don't know. It feels a bit much, but I can understand. You know, it's smooth, it's gold. Meh. And yes, I've almost finished the new version micro ruler. In fact, I've had it manufactured, but I made a couple of little changes. And yeah, there'll eventually be a new crowdfunding for that thing soon. Soon-ish.
R&P Logistics Co. From Vietnam. What is this thing? Switch to next color. What? I don't know. There we go. I'm liking this thing. This is pretty schmick. I got to admit. Okay. Well, I won't use it to open packages. It's good for, like, fine stuff like this, you know, for some finesse. What? Oh, no, we got some blinky. Otatmo. Shining Passion. Oh, God. What? It's a bracelet. It's a flashing lead bracelet. Oh, my... Why? Why? Device on. Turn light off. Turn light on. Change flash pattern. Was it for a rave party or something, is it? Tell you what, you know, if you want to make money, sell flashing LED gadgets to, like, concerts and parties and stuff like that. You instantly got, you know, sale of 10,000 people at the gate who'll, you know, pay anything for a flashing... Why? Why? David's going to... Whoop! David, turn the lights off. Woo! Yeah! That's about... Yeah, that's the gesture you need to make. Yeah. Thanks, David. Whoa! Camera exposure. Shining Passion. Otatmo. Like, do we even, like, is this even worthy of anything on here? It's not even worthy of a 2-minute teardown, is it? Look, there's, you can practically see through there anyway. But they've got to build in the strap. You're like, it's okay. I just, you know, like, yeah, I don't know. Anyone want to go to a rave party or something? Woohoo! Like, check out my funky armband. Oh, man. Oh, that's just tragic. That is tragic. Hold it down. Should go off. Ah, fades out. Ah. Ah, gilded the lily. Made in Vietnam for those playing along at home. Tatmo, light band. I don't know why this product exists, but it's kind of reasonably engineered. I actually don't mind it at all. Look, there's the buttons either side for the pushing down on that thing. So it's not too shabby. Hi to all my viewers in the old dart, and thank you very much, Paul Compton from Luton in the old dart. The old dart is England, in case you didn't know. Let's open it up. Okay, you want to see me use the right tool, don't you? I know you do. Oh, it's... wasn't that effective in that particular situation. Oh, we got... It's going to be something retro, is it? We've got a note. We've got some old relays. Wow, this one's potted. What on earth is that? I should read the note. I'll show you that up close. That is weird. Whoa! A Thander. Oh, wow. Thander frequency counter. Oh, is it 5 meg to 200 meg and 20 hertz to 10 megahertz? Oh, that's crusty as. Oh, wow. 2-minute teardown. So Paul saved this rather tragic-looking Thander frequency counter from the Weebin. Sounds worse than it actually is, but the waste electronic hazardous substances thing. If they contain lead, they've got to throw all these old products out. Anyway, do-it-yourself solid-state relays. There you go. These are like, I'll show you these. Look, resin encased. Beautiful. Look at that. So designed for, they were, which had 240-volt coils, would reset his micros and stuff like that. Reset 80188. Oh, beautiful. Even though it was a separate output of the transformer. So there was enough interference from that switch in to reset the micro. So made his own little potted, encapsulated, solid-state relay. That gets a thumbs up. Beautiful. Oh, hands up if you had one of these. The PFM 200A function gen. Oh, goodness. Let's crack it open. Seriously. What the hell is that? Is that like squish some spider in there or something? Look at this. It's all on all the feet. What? It's wrapped in plastic for our protection. There you go. Whoa. Popped right off. Oh, there you go. That was to protect it from the shield, which wasn't
Oh yeah, they got a little flappy bit of metal there to connect. None of that spring rubbish. And does everything else just hinge out? Whoa. Oh, we've got the National, is that the old National semiconductor lead bubble display? Is that a genuine National? Pretty sure it was National. Who did that one? Not sure. Got anything on the bottom? No, it's not. Okay. It's a cloney one. Anyway, lead bubble display. They're tiny little LED displays, and the bubbles just act as magnifiers to make the digits look a little bit bigger. Anyway, no surprises for finding the Intercell 7216. That's a counter display driver basically designed for these applications, and a prescaler on the input somewhere in there for those playing along at home for the 200 megahertz range, because this thing only has a capability of 10 megahertz or something like that. So yeah, that's all she wrote for a frequency counter. Good enough. Handy little device back in the day. Hands up if you're still using one. Oh, thermistors made in the old dart. Wow, look at that. What vintage are they? Anyone? So thanks to everyone who sent something into today's mailbag. There was some interesting stuff in there. And sorry if I haven't got around to yours yet. I kind of just pick them randomly off the shelves. Anyway, if you liked mailbag, please give it a big thumbs up. Catch you next time.